from our previous unit that said when we multiply xa times xb, remember what we do with our exponents? That means that you add your exponents, so remember that. So the example would be like x to the third times x to the 3 would be x to the 5th. So remember this from our last chapter, that you add your exponents when you do that, so that we can do this part of the notes. Okay, so like here on number 1, I'm going to treat this as if there is a 1 in front of the h, or just a 1 as an exponent. So I want to rewrite this a little bit larger, and I'm going to put coefficients in front of them so that now I can distribute. Hope you remember that word from way back when, the distributive property. Okay, so that I'm going to actually multiply this monomial that's on the outside times the binomial that's on the inside. So when I multiply, I'm going to do 1h times 1h. And remember this rule, the coefficients I'm multiplying, 1 times 1 is still 1, but the h's have exponents of 1s. So when I do h times h, that's 1 plus 1, which means I actually now have 2 h's. And then I have to multiply the next term, 1h times the 4. Well, the 1 times 4 is 4, and then here's an h to the 1, and there's not an h, so I just bring the h over as part of your answer, and then circle it. That's it. So when I go to number 2, I have 1k, parentheses, and then this one will be a 1k minus 9. Remember, the k's have exponents of 1s. So I'm going to multiply, distribute. 1 times 1 is still 1. K1 and K1 is now K2. And now I've got to do the next term. 1 times a negative 9 is negative 9. And K1 and nothing means I just bring the K1 over, and there's my answer. On number 3, the coefficient out front, which is the monomial, is 9a, and then the binomial on the inside has an a, so I'm going to put a 1 with it, and then the plus 1. I'm going to distribute. So 9a times 1, or 9 times 1 is still 9. And a1 and a1 is now a2. And now do the second term. 9 times 1 is 9. And then the a to the 1, just bring it over, and there is your answer. Okay. Let's go with number 4. This has 6p, which is 1, as an exponent. Then the p by itself has a coefficient of a 1, and this has a minus 8. Let's distribute. 6 times 1 is still 6. P1 times P1 is now P2. And I have my negative, or my subtract, because 6 times 8, or negative 8, is a negative 48, and then I bring the p over as well, the p1, and there's your answer. Okay. Alright, now what if I have coefficients everywhere? So like here on number 5, I have 3c, and this one I don't have to rewrite because there's coefficients on every one of my terms. So I'm first going to multiply 3 times a negative 2. 3 times negative 2 is negative 6. This is C1, and C1 is now C2. And then I need to multiply 3 times a negative 5, which is a negative 15. And here's a C1 with nothing, so I bring it over and circle it. There's my answer. On number 6, now they changed my coefficient here, or they changed my monomial in the front. It says a g squared, or g with a little 2. I'm going to treat it the same. I'm going to multiply -4 times 2 and get -8. But now I have g2 and g1. That now gives you g3, because remember, add your exponents. And now -4 times 7 is a -28, and this is a g2 and nothing inside, so that means I just carry the g2 over, or g squared. And there's your answer. Okay. If I go on to number 7, they took the 1's away, so let me rewrite it. So I have 1x and 1x squared minus 1x plus 3. So I inserted the 1's in front just so we know what we're doing. 1 times 1 is still 1. x1 and x2 is now x3. Now let's go to the middle term. 1 times a -1 is negative. Okay, if we look at number 7 right here, I have understood 1's in front of those, so if I rewrite this, I'll have 1x, parentheses, 1x squared, minus 1x1, and then a plus 3. And let me zoom in a little bit. I'm going to multiply 1 times 1 and come out with 1. x1 and x2 is now x3. If I multiply it times the middle term, 1 times a -1 is -1. But x1 and x1, add them up, gives you x2. And now multiply it times the last term, 1 times 3, which is 3. x1 and no x gives you just x1. And there is your answer for number 7. If I look at number 8, the middle term does not have a 1, so I'm going to slide a 1 right there just the way it is. And I'm going to multiply it. 5 times 3 is 15. M2 and M2 now is M4. Because add your exponents. If I go to the middle term, 5 times a -1 is a -5. M2 and M1 is M3. Then go to the last term. 5 times a -7 is a -35, and then I carry the M over, and there's your answer. Okay, if I go to your number 9, notice this one right here in the front has an n squared, so that means there's an understood 1. If I can write it really small right there, I'm going to multiply -3 times 1, which is still -3, but n1 and n2 is now n3. I go to the middle term. -3 times -2 is a positive 6. n1 and n1 is now n2. And then the last one, -3 times 8 is -24, and I carry my n over, and there is your answer. Okay. Come back to number 10. Look at it, I have all my coefficients, so I'm just going to distribute the -2x times each one of these. So -2x times 6x squared, -2 times 6 is -12, and that becomes x to the 3rd power. Go to the middle term, -2 times a -12 is a positive 24. x1 and x1 is x squared. And then the last term, -2x times 18 is a -36x1, and there's your answer. On number 11, they are missing all their 1's inside here, so I'm going to go ahead and rewrite this one. just for safety's sakes, so I can look at everything. And if I multiply this in, 3 times 1 is still a 3. x1 and x2 is now x3, and then they have the y. I don't have a y in here, so just bring it over as it is. If I go to the middle term, 3 times 1 is still 3. x1 and x1 is now x2. y1 and y1 is now y2. So I just combine them, just same pattern as I did my x's. Now go to the last one. 1 times 3 is 3. There's not an x, but I have an x on the outside, so that's x1. The y's, y1 and y2, add them up. I have 3 of them, and there is your answer for number 11. Okay, on number 12, we have coefficients on everything, so we're just ready to multiply. 5 times negative 2 is negative 10. So now look at your r's. We have r2, and r2 gives you r4. s2 and nothing just means you have s2. Now let's go to the middle term. 5 times 3 gives you 15. r2 and r1 give you r3. And then the s's, s2 and s1 gives you s3. Let's go to the last term. 5 times a negative 4 is a negative 20. And then I have an r squared, but the s's, I have s2 and an s2 gives you s to the 4th power. And there's your answer. Okay. On 13, we've got our a's and our b's on this one. We have coefficients, so let's just multiply. 3 times 4 is 12. Now our a's, we have 1 on the outside, 2 inside. That gives you a total of 3 a's. And then we just have a b on the outside. Multiply it times the next one. 3 times a negative 7 is a negative 21. Then I have to bring the a from the outside to a1. But then a b1 and a b3 become b to the 4th power. And there's your answer. On 14, we have c's and d's. We have coefficients, but now they lead with a negative, so this is where my signs are I got to be careful. Negative 4 times 9 is a negative 36. And now the c's. There's 3 and 2 give you a total of 5 c's. And then look at your d's. I have d2 and d2 give you d to the 4th power. Then I go to the next one. Negative 4 times a negative 4 turns that to a positive, and 4 times 4 is 16. I have c3 and c1 gives me a total of c4. And then d2 and d5, that's 7. And then circle it, there's your answer. Okay, 15, last one in this section before we change. We have coefficients, we're just going to multiply. 10 times a negative 2 gives me negative 20. And now we got a bunch of m's. M4 and M1 give me M5. The n's, we have N1 and N3 give me N4. Let's go to the last term. 10 times 3 is 30, and then I just carry my m to the 4th over. But now how many n's? One outside, one inside gives you a total of 2 n's, and there you go. Okay, on the next section they want me to distribute, but then I have to simplify it, make sure I can combine like terms. That's what simplify means. Look for like terms. Okay, and then they want to make sure that my final answer is in standard form. And remember, that's order. Very important. We've got to pay attention to our order. So if I look at 16, I see I have the parentheses, so this monomial, this negative 2x, I have to multiply it times this binomial first. So I'm going to multiply negative 2 times 3 and end up with negative 6. Now the x's, x1 and x1 becomes x2. Then I'm going to multiply it times the next item. Negative 2 times a negative 4 turns that to a positive 8. And I carry the x over as it is. Then I have to bring down the rest of my problem, which was a plus 7x. Now if I'm looking at it, for my standard form, I want to start with the highest exponent. The highest exponent is this leading number right there. I don't have anything else. These are all x1s. So that means this is my first term of my answer. Okay. But now I've used it. I have these. Remember, we're counting down, so x squared now it goes to the regular x. And notice I have 2 of them. So this is where I'm simplifying. I want to combine those. 8 plus 7 now changes this to 15 x1s, and there's your answer to number 16. Realize it is simplified, and it is written in standard form because I made sure that I started with the highest exponent and I counted down. So this matches for both my standards. Okay, here on 17, just multiply 5 times the negative 7 and I end up with negative 35. And W1 and W1 is now W squared. Let's go to the next term. 5 times 3 comes out 15, and I carry the W over. And now I've got to do the second half, so let me change colors here. I'm going to go to purple, and I'm going to do the same thing. I got my plus sign from here, and then I'm going to multiply 2 times a negative 2, which makes that negative 4, and W1 and W2 is now W3. I go to the next term. 2 times 19 is a positive 38, I believe, and W1 and W1 is a W2. And then I do the last term. 2W times 2 just becomes 4W out here on the end. So now I need to look at what I can combine. So what is the highest term, or what is the highest exponent term? Well, this one's the x squared. That's the x, I'm sorry, not x, W squared, W1, W3, W2, and W1. So there's actually only one W to the third, and it's the highest, so that's going to come out first. So that's my first term that I'm looking at. Now I'm going to count down from this. So I'm looking for squares. And if I look at my values here, let me change colors again. Here is a square term. And on this one, there's a square term. So I need to combine those. So if I'm looking at this, negative 35 plus 38, that comes out as 3, because I actually subtract them. And they both have W squared, so that's what I bring over as a W squared. Now, from the squares, I go to the ones. Well, here's a 15, and on the end, there's a 4. They're both positive, so 15 plus 4 give you 19 W1s, or just W. There's your answer in descending order. That's the standard form. So I had to make sure I wrote these in descending order. Alright, let's go to the next one. 18. Alright, so I'm going to rewrite this with the 1. So I have 1y1 times 1y1 plus 4. Those are y's. They look like 4s. Minus, and this is a 1y times 1 times a 1y1 minus 3, and then on the end I have a minus 9y. So I got a lot of stuff going on here. Let's go with the first one. 1 times 1 is still 1. y1 and y1 is now y2. Let's go to the next term. 1 times 4 is 4, and I carry the y from the outside into my constant. Now let's go to the second term. Negative 1 times 1 is negative 1. Y1 and y1 is y2. Negative 1 times a negative 3 is a positive 3, and I carry the y over as it is. And then on the end I have a minus 9y. Alright, I'm looking for my highest exponents. Highest exponent. So here I see I have a 1y squared and a minus 1y squared. So 1 minus 1, those actually cancel out. They go to 0. So that's gone. So the next highest, if I'm looking through there, I see the y's are the y1s. I didn't put a 1 on that last one, so let me get my red pen here and put a 1. So that I actually see I have 3 of them. I have a 4, a 3, and a minus 9. So I actually need to combine all of those coefficients. So 4 plus 3 is 7. What is 7 minus 9? Well, 7 minus 9 is actually negative 2y1. And there's your answer. Okay? 19. I'm going to do 6x times 2x. Well, 6 times 2 is 12. And x1 with x1 is now x2. Do the next term. 6x times a negative 3. 6 times a negative 3 is a negative 18, and I carry the x over. Take the next term. Negative 5 times 2x squared. Well, negative 5 times 2 is a negative 10, and I carry the x squared over. Multiply the next term. Negative 5 times 9x. Negative 5 times 9 is negative 45, and I carry the x over. And then do the last term. Negative 5 times a negative 3. Negative times a negative turns it to a positive 15. Alright, looking for highest terms. I see, if I'm looking through there, it looks like I have a square, and I have another square. So now the coefficients. 12 minus 10 is 10x squared. Okay. Look at your next terms. I have a negative 18x and a negative 45x. So I need to combine those. Negative 18 and a negative 10 gives me negative 28. x1s, and then last is my constant. There's your answer for number 19. Okay, on 20. We're getting longer and longer with these things. Looks like a monomial times a trinomial and a monomial times a so we have double things going on here. I have coefficients on all of them. So I'm going to just multiply. Negative 2 times 3 m to the third becomes negative 6 m to the third. Then multiply to the next one. Negative 2 times 5m is a negative 10m. And then negative 2 times 6 is a negative 12. Go to the next term. Negative 3m times 2m squared is 6m to the third. Go to the next term. 3m times 3m is 9m squared. And 3m times 1 is just a 3m. Like terms. Notice I have a cube and I have another cube. I have another power of 3. So I look at the coefficients. Negative 6 plus 6 cancels out. That goes to 0. So my next term is looking for a square. That's a 1. There's my square, and I don't have any other square, so this is my first term. So that pulls it out front. Okay. Now look for the ones. Here I have a negative 10 plus 3. Negative 10 plus 3 is negative 7 m1s. And then last is your constant. There's your answer. Okay, here we go with the last one on this page. I'm going to distribute. Looks like 3 times on this one, so I got to pay attention. Negative 3 times 7 is a negative 21, and y1 and y1 makes this y2. Negative 3y times a negative 2. Negative 3 and a negative times a negative turns that to a positive, and I bring the y over. And I'm through with the first set. Let's go with the middle set times a trinomial. So 3 times, oops, there's an understood 1 there. I didn't rewrite this. Make sure you understand there's a 1 right there. So 3 times 1 is 3, and I bring the y squared over. 3 times 2y is now 6y. And 3 times 1 is just 3. I have my trinomial written. Let's slide it over. Let's do the last one. Negative 3y times negative 5y. Negative times a negative turns this to a positive 15y, and then I have 2 y's. And now the last one. Negative 3 times 3 is a negative 9, and then I have to carry the y over from the end, and that's a y1. Alright, I'm scanning through it. I want to find my highest exponents. There's a 2, 1, 2, 1, 2, and a 1. So it looks like 2's are my high numbers. So let me circle those. Okay. Oh, right there. Alright, I'm going to get my calculator for that to make sure I do it right. So I have a negative 21 plus 3, and then I have a plus 15. So I've got all my coefficients. That gives me negative 3, and that would be my y squareds. Okay, so I've used those. Those are gone. Okay, now next, do I have my y's? Here's a 6, and another one right there, a 6, and then I have the 9 on the end. So here we go. Let me add those up. So I have 6 plus 6 minus 9. Oops. Minus 9. And that gives me 3. That's positive, so I'm going to put plus 3, and that was my y's. That's my y1. And then last I have is a constant, so it's just plus 3. And there's your answer. Turn it over. We have just 4 more, actually 5 more with a geometric one. But look at the first one. Oh gosh, dropped my pen. This term in the middle right here has an understood 1 there, so I'm going to put that there. And now I'm going to multiply. 4 times 2 is 8, and x2 and x2 is now x4. Let's go to the next term. 4 times 1 is 4, and x2 and x1 is now x3. And if I go to the last term, 4 times a negative 5 is a negative 20, and then I carry the x squared over. Notice they're in descending order. Now the next term, I didn't put a 1 there, so there's an understood 1 here as well as there. Okay, so now I'm going to do negative 1 times 1, which is a negative 1. x1 and x3 is now x4. And go to the next term. Negative 1 times 5 is a negative 5. And x1 and x2 is x3. And now let's go to the last term. Negative 1 times negative 3. Negative times a negative turns that to positive, and 1 times 3 is 3. I'm going to bring the x from the outside over, so that's x1. And then last, on the end, I have is the 17, so it's plus 17. That's a constant on the end. Okay, now if I go through it, let's see the highest exponents. Here I have x to the 4th, and here's another x to the 4th. So if I look at it, 8 minus 1 is now 7x to the 4th. Alright, those are gone. X to the 3rds. If I look at those guys, I see a 4x to the 3rd and also a negative 5x to the 3rd. So 4 minus 5 is a negative 1x to the 3rd. Alright, do I have any squares? If I'm looking through there, I see a square right here, and that's it. So I just bring that thing down, minus 20x squared. So next I look for the x. Okay, on the x, there's my x and there's a constant, so I just bring that one down just as it is. And then last is my constant, which there is nothing left, so my constant is last, and there is our long answer. There's a definite polynomial. Okay, 1, 2, 3, 4, 5 terms. That's a polynomial with degree 4, which means it's quartic. So this is a quartic polynomial. Alright, 23. On 23, they're just getting more and more difficult and longer. You got to be very careful. There's understood 1 in front of that x to the 3rd, and that's it the rest of the way. So I'm going to multiply. Negative 2 times 1 is a negative 2x, and this is x1, and x3 gives me x to the 4th power. Now I'm going to multiply times the next term. Negative 2 times negative 6 is a positive 12, and x1 and x2 is x3. And then if I go to the next term, negative 2 times 6 is a negative 12, and I carry the x over for next one. If I go to the next term, notice it's just floating around in the middle. There's nothing happening to it, so I'm just going to bring it down. And now here's the trick on the second one. See how it has a minus, and then it has that parentheses? There's an understood 1 in front of that, because I have to actually multiply this negative into my parentheses. So I'm going to do negative 1 times 5. That's just negative 5, and I carry over the x to the 4th. And then I have to do negative 1 times a 10x, so that means that's a minus 10x. So this is the trick right here. That little thing there, everybody always misses that little thing. It's very important. Alright, looking for my highest degree. I see an x to the 4th, and here is an x to the 4th. So I want to combine those. Negative 2 and a negative 5. Negative 7x to the 4th. Okay. Let's go to our next term, which is x to the 3rd. I see a 12 as well as a 4, so combine those. It gives you 16x to the 3rd. Okay, now I'm looking for a square. Do I have any squares? Nope, no squares. So skip that one. Now there's x1, and there's an x1 here, so negative 12 and a negative 10 gives you negative 22x1, and there's nothing left. There is your answer. So this is a trinomial, and the degree is quartic again. Okay, I'm going to do 24 last because it's rather, that is the deluxe whammy one right there. So let's go to 25. I have, let's see, 2 y's on the outside. So I'm going to multiply that times 6x. So 2 times 6 is 12, and then I have an x and a y. I don't have multiple of those, so I'm going to write x first, and then the y, so I have it in the correct order. Then I'm going to go to the next term. 2 times a negative 4 is a negative 8. And I don't have an x on the outside, so carry the x squared down. But now the y's. I have y1, and y1 brings y2. The next term, I'm not doing anything to it, so I'm just going to bring it down. And then I'm also just going to bring the constant down because there's nothing going on. Now I need the highest degree, so let's see here. We have x's and y's, so that means I only pay attention to the x because it's alphabetically first. So I want the highest x. So this is a 1, there's a 2, and there's a 2, and there's nothing there, so that means x squared is my highest degree, so I need to combine. Notice x squared x squared y squared and x squared y squared. Those are exactly the same. So I can combine these. These are like terms. Negative 8 plus 13 is 5 x squared y squared. Now those are gone. After square is the 1, so there's nothing else like this one, so the 12 is next. And it's positive, so put a plus sign. And the constant is last of a minus 6, and there's your answer. Okay, I'm going to do the geometric one first because I'm really saving that one for last. The geometric one says find the area of the shaded region. So they want to find this dark part. Area. Well, area is always length times width. So if I'm looking at these shapes, I have the big rectangle. That's length times width. So if I show this, I'm going to have 6x times this binomial. We always put the binomial inside. So this is the outside, the big box, or the big rectangle. Okay. The small rectangle on the inside, I have a 2x is my length, and my width is 5x plus 3. So this one's the small rectangle. Okay, so I need to find these two areas. Well, to do so, I'm going to distribute the 2 into my parentheses. So that would be 2x1 times 5x1. Well, 2 times 5 is 10, and x1 and x1 is now x2. And then I'm going to multiply the next one. 2 times 3, which is 6, and I carry the x over as it is. So this is my area of my smaller rectangle. Okay. I go to the other side. I'm going to distribute just like I did on the other side. 6x times 8x. Well, 6 times 8 is 48. And x1 and x1 is x2. And then multiply the next term. 6x times a negative 1. 6 times a negative 1 is a negative 6. And I carry the x over. So this is my area of my big triangle. So I'm going to put this as, oops. Okay, let me wipe that out. Okay, so we're going to make this one our small rectangle, and we're going to make this one our big rectangle. So this is our area of our big rectangle. That's a B. And this is the area of our small rectangle, so I'll make that one an S. Okay. Now, if I'm thinking about this, they want the area of the shaded. So I actually need to find the area of the big rectangle. Once I have that area, the big rectangle, and I have my small rectangle's area, what do you think I need to do with those two? Since this is white on the inside and this is shaded on the outside, this represents a hole. This is missing. Okay? This is missing in the big rectangle, so that means I have to subtract those two things. So if I'm subtracting, the big rectangle was this expression. right? This represented our big rectangle. The small rectangle was this expression. And I had to subtract. Notice I put these in parentheses. These are together and these are together. So that, realize, there is an understood 1 right there, and I have to distribute that into my parentheses. There's an understood 1 in front of this one. I need to distribute that into my parentheses. When I do so, 1 times 48x squared is still 48x squared. And 1 times a negative 6x is still a negative 6x1. But on the other side, negative 1 times 10x squared, negative 1 times 10 is a negative 10x squared. And on the next one, negative 1 times 6 is a negative 6x1. What's my highest exponent? Happens to be the squares. So I actually need to do 48 minus 10. Well, that's 38x squared. After the squares, I need to go to the x's, or the x1s. Notice I have a negative 6x1 and a negative 6x1. Well, negative 6 and a negative 6 is a negative 12x1. And there is your area of your shaded region. Okay, here we go. Let's go back to 24. Now, I skipped 24 for a very important reason. Do you see why? Okay, hopefully you see these little symbols. Let me get my highlighter. Okay, if you notice, this one has brackets. So order of operations tells you to do parentheses and brackets, and you work your way out from there. So I want to do the brackets last. I have to go inside here first. So I'm not touching the 4b on the outside. I'm just going to bring it down, my first step. Okay, I'm just going to bring it down, and I'm bringing my brackets down the way they are. The 2a squared, nothing is happening to it, so I'm just going to bring it down. But now, right here, this has another set of parentheses. So I have to multiply negative 5 times each term here. So negative 5 times 3 becomes negative 15a. I'm sorry, 15. And then the a and the b are just brought down because there's nothing on the outside. And I have to do that times the next term. Negative 5 times negative 2 is a positive 10. And then there's nothing here, so I just bring the b squared down. Okay. Now, I'm going to treat these brackets as if they're parentheses, so that my next level, I'm now going to distribute the 4b into my parentheses. So 4 times 2 is 8, and I have an a squared, and I have a b on the outside. There's my first term. Let's go to the next one. 4 times negative 15. Well, let me make sure I don't mess up. 4 times negative 15 is a negative 60. Okay, so I have an A, and now I have 2 B's. Okay, now the last term. Go on out. 4 times 10 is 40, and I have a B1 with B2. That gives me B3. Okay, I'm finished now with the first term. So now don't forget about that last term here. So now I have a plus 29ab squared. So remember, we're looking for the highest exponent of the first letter of the alphabet. So if I'm looking through these, let me get my green here. I'm looking for the A's. Here's an A2, there's an A1, no A whatsoever, and here's an A1. So the highest A is already in the front position. So that's my first term. So that one's gone. I just used it. Now let's count down. I need an A1, and here's an A1. Notice your B's are the same. Since they're the same, now I can combine those guys. So negative 60 plus 29. Okay, that gives me negative 31. And that would be an A1 and a B2. So now that one's gone. And what's left is the 40b to the third. And there is your answer. Okay, that's the mega one right there, I think. You guys might think the one on the bottom here was the big one. Alright.